here we're going to look at an example of writing a quadratic equation from a graph. Okay, before we get started though, we want to go over the different forms of writing quadratic equations. So there's three different forms. The first one is standard form, which is y equals ax squared plus bx plus c. The second one is intercept form, which is y equals a times x minus p times x minus q. We usually use this when we have the x-intercepts. And then we also have vertex form as our third and final form, which is y equals a times x minus h squared plus k, where my vertex is at hk. Now, some things to note when looking at these three equations. You'll notice they all have an a value. The a value will tell us how much the graph is stretched or compressed. Okay? So we will have to find a in order to write a quadratic equation, because without it, every form uses it. We got to be able to find a to write the quadratic equation. So if we take a look at example 1 here, we'll notice that we have the graph that crosses the x-axis at 2 and 4 and then has its vertex at the point 3, 4. So the first equation that we want to write is an intercept form. Well, if you remember, intercept form is always the opposite of the insides is where our x-intercepts are. So if I want to write an equation for this in intercept form, I'm going to have y equals, I'm going to leave space for my a because I don't know what my a is yet, but it's going to be x minus 2 and then x minus 4. Okay, because wherever my x-intercepts are, it's the opposite of what's on the inside. So if I have an x-intercept at 2, I'm really going to have a minus 2 on the inside. And if I have an x-intercept at 4, I'm really going to have a negative 4 on the inside. Now the reason why that is if you look at your graph, you'll notice that the y-coordinate at the x-intercepts is equal to 0. Right? Y's got a value of 0 at the x-intercepts. And you'll notice if I plug a 2 in, 2 minus 2 is 0. And if I plugged a 4 in, 4 minus 4 is 0. So it's always going to be the opposite of what your x-intercepts is. Alright, now to end the problem, all we need to do is find our a. Our a is always the stretch or compress. It's kind of like the slope, but it's always over 1. So when we move one distance over, 1 unit over, how much does our graph change? Well, in this case, we go from 4 down to 0. So our graph went down 4. So if I want to know what a is, it's my rise, which in this case is negative 4, over my run, which is always going to be 1. So my a is negative 4. So the equation for this graph in intercept form is y equals negative 4 times x minus 2 times x minus 4. Now, we can also write the equation for this same graph using vertex form. So in vertex form, right now I have the vertex at 3, 4. And in vertex form, I want it in y equals a times x minus h squared plus k. Now the thing to remember is the h is always the opposite of what the vertex is. So in this case, if I have a 3 as my x coordinate, it's going to go in for the h as a negative 3. The y value, on the other hand, will stay the same when I plug it in for the k. And then once again, my a value hasn't changed from intercept form. It's still going to be negative 4. So if I want to write this in vertex form, I'm going to get y equals negative 4 x minus 3 squared plus 4. This will be the equation in vertex form. Now with vertex form, you always could check your work. You should notice that if you were to plug in 4, you should be able to get 0 out. You should be able to get this x-intercept. So for instance, if I were to plug in a 4 value into my function, well, 4 minus 3 would give me 1, and 1 squared is still 1. And then if I take negative 4 times that 1, I'll get negative 4. And then when I take negative 4 plus 4, I will indeed get 0. And that's what I should get, because when I plug 4 into my function, I should be on the x-axis, and my y value should be 0. So this function, y equals negative 4 times x minus 3 squared plus 4, is the equation for this parabola in vertex form.